So this is just a short video about a prototype module. The prototype module is this white one here. Ignore the black, that's made by a friend. This is a prototype of a module I'm calling Kickflip. I've been working on variants of this for a while, and in short, it's a thing to process foot pedal presses. By which I mean this is a standard sustain pedal, momentary foot switch, push to make, and it terminates in a mono jack, and when you push it, it connects one end to the other, and you put that in this big jack socket, and then these outputs do things dependent on your presses. I'm going to walk through them top to bottom, and we'll just ignore the blinking one for now. So the very first output is called gate, and literally when you push the pedal, it goes high. When you let go, it goes off. On, off. Next one down is called tap. Tap goes off when you give it a brief push. Note that it's on the rising edge of the pedal rather than the falling edge. That's for a reason, which we'll come back to. You can change that with a jumper on the back, but by default, gate is on just whenever the pedal's on. Tap is on at a rising edge. The third one down is called hold. When you hold the pedal for more than half a second, hold goes high. When you let go, it goes off. And you'll note that on the rising edge of a hold, there's no tap output. Tap is mutually exclusive to hold. And that means you can have two different actions, one wired to hold, one wired to tap. For instance, like clearing a buffer in a looper, and they don't get in each other's way. Fourth jack at the bottom is just called toggle, really simple. Alternates on every pass, on and off, like that. And then finally we've got this fifth one that hasn't gone on very much, and this is called double. And this sends out a brief burst on the second tap of a double tap, like so. And you'll also note that on a double tap, the first tap emits a tap, but the double tap doesn't emit a tap output, it just emits a double output. You'll also note that this blue light was coming on. That's actually a button, and everything you can do with the pedal, you can do with the button, and they don't interfere with each other. So finally, there's a blinking output here and a toggle switch. You'll notice at the moment, nothing I do with the pedal interferes with the toggle. But when I flip the toggle down, these 5 jacks no longer are affected by the foot pedal, but this one is. And the 6th jack is tap tempo. And when you flip this switch, you can set a tap going and then put the safety catch, as it were, back on. So this basically lets you choose whether you're doing momentary outputs or the pedal. And that's it. One other neat touch, it currently is working with a push to make switch. If you have a push to break pedal, the module actually looks at whatever's in here at power up and it decides that's the default. So if you were to put a push to break pedal in here and turn the module on, it would work fine, and so would the button, so it works either way around. There's one other neat trick up this pedal sleeve, this module's sleeve, that I want to show you, and I'm going to do so by taking it out of the case. So here's the module taken out of my case and propped up against my Leatherman. On the back, fairly basic connectors, power connector, a pair of jumper headers for whether you want trigger and double and hold to be mutually exclusive or not, and also which edge you want the rising edge of the tap output to be. Currently nothing on them, so it's behaving in the defaults. This is a programming connector that you don't actually need to put pins on, and I probably wouldn't in the final thing. I've just been using that for debugging it, and there's our jack socket. But the interesting thing is here. So on the edge, you'll see there's a micro USB socket. And what you'll discover is if you plug this into your computer over micro USB and double tap the reset button there, which you can just reach in with a finger or a knife, it'll mount on your desktop as a drive. And you can take a brand new firmware file, a UF2 file, which is a special format you can make, and you can just drag it over. So that means if there's a firmware update, you don't have to do anything with DFU or Arduino or anything like that. You just put it into your computer, drag the file over, it reboots itself with the new firmware. But if you are a hacker and you want to play with this, the other neat thing is if you plug the USB socket into your computer, this will actually just mount in the Arduino IDE as an Arduino Zero. It's got a ARM SAMD21 chips, that's a Cortex M0 Plus, and basically it's behaving, it's got the UF2 bootloader on it, which means it behaves like an Arduino Zero or an Adafruit Feather M0 or anything with a SAM21 chip in. So that means if you want to make your own modifications, it's really easy to. You just plug it in, and it works like that. So that's it. That's Kickflip. That's 6 HP, and I have no idea what I'm doing with it, but who knows? I'll just put up an image of the current panel design at the end to show you. Okay.